Hello, Chemistry 1B students. This is Mrs. Crumshredder with some corrections for ChemQuest 39 Intro to Moles. So, information thinking in quantities. A mole is simply a quantity of atoms, just like a dozen is a quantity of eggs. If you have 2 dozen eggs, we know you have 24 eggs. Similarly, chemists can speak of having 2 moles of carbon atoms or 4 moles of water molecules. Just like the number 12 goes with dozen, there is a number that goes with a mole also, but we will worry about that later. Below are 2 pictures of containers that contain atoms of neon gas. There are a lot of atoms of neon in each container. This container represents 1 mole of neon gas. The gas has a mass of about 20 grams. This container represents 0.5 moles of neon gas. This gas has a mass of about 10 grams. In the following container, put the correct number of atoms, black dots, to represent 2 moles of neon gas. So notice here we have 6 dots. It's 1 mole, and it has a mass of 20 grams. Here we have 3 dots. It's half a mole, and it's 10 grams. So now we want to have 2 moles, which is going to be twice as much as this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I should have 12 dots here because I need to have twice as much as I have here. What is the mass of the gas in the container in question 1? Well, if 6 dots has a mass of 20 grams, then 12 dots is going to have twice the mass, so it's going to be 40 grams because 2 times the amount. Draw black dots to represent neon atoms. Place 30 grams worth of neon in the following container. So again, this was 2 moles, and it was 40 grams. Now we want 30 grams, which is halfway between these. And this has 12, or this has 6, and this has 12, so that would mean a total of 9 dots. And where you put them doesn't matter. The container in question 3 contains blank moles of neon atoms. So again, we know that this is 30 grams. And again, up here, this was 1 mole. This was 2 moles. So this is 1.50 moles. Because it's halfway in between. Each black dot in the above example stands for this many atoms. Approximately how many atoms are in 1 mole? So 1 mole was 6 dots. So it would be this number times 6, which is 6 with all these zeros. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? So that's approximately how many atoms are in a mole. Quite a large number, which should sort of make sense because remember, atoms are really, really tiny. So atomic mass using atomic mass units and grams. 1 atomic mass unit is equal to 1.6611 times 10 to the negative 24th grams. So this is like a conversion factor, right? 1 AMU over 1.6611 times 10 to the negative 24th grams. Or, depending on where I need my units to be, I might have to use it this way. Oops. Okay. So that's my conversion factor. That's why that information is given. According to the periodic table, a single carbon atom has a mass of 12.011 AMUs. Let's talk about just a moment where that comes from, right? So that's using this number right here, okay? What is the mass of a single carbon atom in grams? So this is asking me to take 12.011 AMUs and figure out how many grams that is. So 12.011 AMUs, okay, per carbon atom, because that's what they told me, right? It's the mass of one carbon atom, and we want to know the mass of a single carbon atom in grams, okay? So AMUs has to go on the bottom, and grams are going to go on the top. I'm using this one here. So in front of grams is 1.6611 times 10 to the negative 24. And in front of AMUs is 1. AMUs have crossed out, and I'm left with grams of a carbon atom. Right? In my calculator then. 12.011, I'm multiplying because 1.6611 is in the numerator. And I get, and I'm going to use 1, 2, 3, 4, 5. I'll use 5 significant figures. So 1, 2, 3, 4, 5. 1.9951 times 10 to the negative 23rd grams per carbon atom. Okay. Question 7. How many carbon atoms does it take to equal 12.011 grams? So basically this is saying if I have 12.011 grams of carbon, how many atoms of carbon do I have? So I'm going to start this with my 12.0 grams of carbon. I'm going to use this answer that I just had, which has grams and carbon atoms on the top. And we said one carbon atom had a mass of 1.9951 times 10 to the negative 23rd grams. Now, instead of rounding, I'm just going to go ahead and use this answer. So I'm going to say 12.011 divided by second, and I'm going to say answer, which is down here, okay, right here. And here's my answer. Again, I'm going to use 5 significant figures, so 6.0201 times 10 to the 23rd carbon atoms. So, for a moment, let's take a moment and think about what this is saying. This is saying that if I have the mass from the periodic table, okay, in grams, I have 6.0201 times 10 to the 23rd carbon atoms. Okay. Let's look at our next question. According to the periodic table, a single phosphorus atom has a mass of 30.973 AMUs. What is the mass of a single phosphorus atom in grams? So this is just like number 6. So I'm going to start with my 30.973 AMUs per phosphorus atom. AMUs has to go on the bottom. Grams goes on the top. It's 1.6611 times 10 to the negative 24. Grams is 1 AMU. Again, that's that information that was given right up here. Okay. And we're going to have grams per phosphorus atom, which is what we want. So, again, I'm going to take 30.973 times 1.6611 E negative 24. Okay, and I get, and I'm going to use 5 significant figures again, 5.144, 9 times 10 to the negative 23rd grams per phosphorus atom. How many phosphorus atoms does it take to equal? And again, you guys, notice this number, right? 30.974. That's the number we're using here. Okay, they use 3, but pretty much the same. So 30.973 grams. We know it's 5.1449 times 10 to the negative 23rd grams per 1 phosphorus atom. So, again, I want to use that answer I already have. So I'm going to do 30.973 divided by second answer. And again, I want to use 5 significant figures. So I'm going to have 6.0201 times 10 to the 23rd phosphorus atoms. So again, let's talk for a moment about what this is saying. For the first one, when I take this mass on my periodic table and I have it in grams, I ended up with 6.0201 times 10 to the 23rd carbon atoms. When I take phosphorus's mass from the periodic table and then express it in grams, I end up with 6.0201 times 10 to the negative 23rd, times 10 to the 23rd, okay, phosphorus atoms. I hope you see a trend. Guess for a moment, if I had 15.999 grams of oxygen, how many oxygen atoms do you think I would have? I hope you had said 6.0201 times 10 to the 23rd oxygen atoms. That's not a quinky-dink, okay? Notice that the answer here and the answer here ended up being the same. So number 10 asked us to compare our answers to questions 7 and 9. Okay, they are the same. Okay. And again, it's what we just talked about. If I take my atomic mass from my periodic table and express it in grams, and I want to know how many atoms of that element it takes to make that many grams, it's always going to be 6.0201 times 10 to the 23rd of those atoms. So, what is a mole? Hopefully you found that your answers to questions 7 and 9 were about the same. Both answers should be about 6.02 times 10 to the 23rd. The quantity 6.02 times 10 to the 23rd is Avogadro's constant, and we call it the mole. Just like the quantity 12 is called a dozen, so the quantity 6.02 times 10 to the 23rd is called a mole. By definition, a mole is the quantity of atoms necessary to equal the element's atomic mass in grams. So, according to the periodic table, 1 atom of sodium has an atomic mass of 22.99 AMUs. If you weighed out 22.99 grams, on a balance, you would have 6.02 times 10 to the 23rd atoms of sodium present. Okay, so key being here, one atom we measure in AMUs. Avogadro's number or constant of atoms, we measure it in grams. Okay. Look at your periodic table and find gold, atomic number 79. What is the mass of one gold atom? You should note that one gold atom has a mass of 196.97 AMUs. How many gold atoms would you need to get 196.97 grams? You would need to put 6.02 times 10 to the 23rd atoms of gold on the balance before you would have 196.97 grams of gold. 1 mole of an atom will always equal the atom's atomic mass in grams. What is the mass of one atom of aluminum, including our units? So this is asking us to find aluminum and find our mass, which is 26.982. So I know my number is going to be 26.982. But notice I'm asking the mass of a single atom, which means my unit should be in AMUs, atomic mass units. If you had Avogadro's constant, or 1 mole of atoms of aluminum, what mass of aluminum would you have? Include your units. So now, because I have Avogadro's constant of atoms, or 1 mole, okay, so because we have 1 mole, we would have 26.982 grams of aluminum. So again, 1 atom, we measure it in AMUs. If we have 1 mole of atoms, or 6.02 times 10 to the 23rd atoms, then we're going to have the atomic mass from our periodic table in grams. So what is atomic mass? Okay. It's the mass of a single atom usually measured in units of AMUs, or atomic mass units. Next question. If you had 1 mole of pennies, how many pennies would you have? Again, 1 mole is the special number. It's the 6.022. I usually put an extra 2 on there, times 10 to the 23rd. Okay, just like 1 dozen is 12. So if I have a mole of pennies, how many pennies would I have? I would have 6.022 times 10 to the 23rd pennies. If you have 3 moles of sand, how many grains of sand would you have, right? 3 moles. 1 mole is 6.022 times 10 to the 23rd. So I'm going to multiply. And I get 1.807 times 10 to the 24, okay, grains of sand. Just as atomic mass of an atom, molecular mass is the mass of a molecule. It is found by adding up all of the masses of the atoms in the molecule. Because ionic compounds are not properly called molecules, the term formula mass is used in place of molecular mass for ionic compounds. Consider the following examples. The atomic mass of hydrogen, 1.0 AMUs, and the atomic mass of oxygen is 16.0 AMUs. 1 molecule of water has a molecular mass of 18.0 AMUs. This number is obtained by adding the masses of 2 hydrogens, each at 1 AMU, and the mass of 1 oxygen at 16 AMUs. Aluminum chloride has a formula mass of about 133.5 AMUs. This is found by adding the mass of 1 aluminum atom at 27 AMUs to the mass of 3 chlorine atoms, 3 times 35.5 AMUs. Verify this with your calculator. So they're just saying here, take 27 plus 3 times 35.5, and you get 133.5 AMUs. Just as 1 mole of atoms equals the atomic mass of an atom in grams, so also 1 mole of molecules equals the molar mass of the molecule in grams. Molar mass is the mass in grams per mole of 1 mole of a substance. Therefore, we expect 6.02 times 10 to the 23rd molecules of water will have a mass of 18 grams, and 6.02 times 10 to the 23rd formula units of aluminum chloride will have a mass of 133.5 grams. We say then that the molar mass of water is 18 grams per mole, and the molar mass of aluminum chloride is 133.5 grams per mole. Number 16, verify using a periodic table and calculator that the molecular mass of N2O5 is approximately 108 AMUs. So N and O, and normally this would be something you would not have to show your work for, but I'm going to show it so you know where these numbers come from. So I look up nitrogen on my periodic table, it's 14.007, and oxygen is 15.999. So 14.007, 15.999. Those are my numbers from my periodic table. So now 2 times 14.007, okay, which is 28.014. 5 times 15.999, okay, which is 79.995. I'm going to add to that the 28.014 because I'm adding these two together, and I get 108.009 AMUs. How many molecules of N2O5 are equal to 108 grams? This is my mass of 1 molecule, right, of N2O5. If instead I have 108, the molar mass, but in grams, remember that means that I have 1 mole of N2O5. Therefore, I have 6.02 times 10 to the 23rd molecules of N2O5. Okay, that's the difference between measuring something in grams and measuring something in atomic mass units. Atomic mass units means I'm talking about a single molecule or a single formula unit or a single atom. When I talk about that same mass in grams, now I'm talking about 1 mole of molecules. Why is the term molecular mass applied to water, but the term formula mass applied to aluminum chloride? That's because water is a molecular compound, which remember means that it has a covalent bond. It's made of 2 nonmetals, and the smallest piece of a molecular compound is called a molecule. Therefore, we call it a molecular mass. By contrast, when we talk about aluminum chloride, this is an ionic compound. That means it has an ionic bond. That means it's made of a metal and a nonmetal. Or remember, it has a polyatomic ion in it. And we call the smallest piece of an ionic compound a formula unit. Therefore, I can't call it a molecular mass because that is specific for molecular compounds. I'm going to call this a formula mass. Okay, so question 19 asks us to find the molecular or formula mass of each of the following, including units. Now, again, I'm talking about molecular formula mass. I'm talking about one formula unit or one molecule. What do you need, Joe? Because I can't pause this very well. Okay. So, find the molecular or formula mass of each of the following, okay? So, because I'm going to be talking about one formula unit or one molecule, remember my units are always going to be atomic mass units. Now, here is where we need to talk about the fact that you have to have learned how to write the formulas for ionic and molecular compounds. Because I've given you a name here, actually the author of this gave you a name, right? So, this is a metal and a nonmetal, which means that it's an ionic compound. So I'm going to do symbols, charges, crisscross, lowest whole number ratio. So my symbol for magnesium is Mg. It's in group 2A, so it has a charge of positive 2. Phosphide is phosphorus with a charge of, it's in group 5A, negative 3. I crisscross down, and so I have Mg3P2. So for magnesium, I have 3 of them. For phosphorus, I have 2 of them. I'm going to use my masses from my periodic table. So magnesium is 24.305. Phosphorus is 30.974. So and then I'm not going to kind of write them out separately, right? I'm just going to kind of do them all at once on the calculator. So 3 times 24.305 plus 2 times 30.974. And I get 134.863. It's going to be AMUs because I'm talking about 1. And this technically would be a formula mass, right? Because this is an ionic compound. Letter B is over here, sodium sulfate. Again, this is an ionic compound. Sulfate is one of the polyatomic ions you have memorized. So my symbol for sodium is Na. It has a charge of +1. Sulfate that you have memorized is SO4 with a charge of -2. So my formula is Na2SO4. So now I have sodium and I have 2 of them. I have sulfur, I have 1 of them, and I have oxygen, and I have 4 of them. Okay, so again, I'm going to use my periodic table to find those masses. So sodium's is 22.990. Sulfur is 32.065. And oxygen is 15.999 again. And again, I'm going to add those all together. So again, 2 times 22.99 plus 32.065 plus 4 times 15.999. And I get 142.041. And again, this is atomic mass units because I'm talking about this. And again, this would technically be a formula mass because this is an ionic compound. Letter C. Okay, this is calcium nitrate. So this is going to be, again, another formula mass because this is an ionic compound. I have calcium, nitrogen, and oxygen. 1 calcium, I have 2 nitrogens, and I have 6 oxygens. Oxygen is still 15.999. Nitrogen is still 14.007. And calcium from my periodic table is 40.078. Again, I'm going to add those all together. So I have 40.078 plus 2 times 14.007. Oops, too many zeros in there. Okay. Plus 6 times 15.999. and I get 164.086 atomic mass units. Lastly, we have C2H8. This would actually be a molecular mass because this is a molecular compound because it's made of two nonmetals. Carbon and hydrogen, 4 carbons and 8 hydrogens. Carbon's number from our periodic table is 12.011, and hydrogen's is 1.0079. Okay. So again, I'm going to add those together. So I have 4 times 12.011 plus 8 times 1.0079, and I get 56.1072 atomic mass units, and again, that would be a molecular mass. Find the molar mass of each of the following, including units. So because this is asking for a molar mass, we're talking about 6.02 times 10 to the 23rd, either molecules or formula units, which means the units for these are going to be always in grams per mole. I still do them the same way. So I have calcium and chlorine. I have 1 calcium and 2 chlorines. Again, calcium is 40.078. Chlorine is 35.453. Okay, and I'm going to add them together. So 40.078 plus 2 times 35.453. And I get 110.984, but this time grams per mole because I'm talking about Avogadro's number, okay, or constant of formula units in this case. Barium nitrate. Again, they didn't give me the formula, so I have to write this. Nitrate is one of the polyatomic ions you have memorized. So again, that means that this is going to be symbols, charges, crisscross, lowest whole number ratio. Okay. So I have barium with 1 of them, I have nitrogen and 2 of them, and I have oxygen and I have 6 of them. Okay. Barium on my periodic table. Oops, struggling to find barium. There he is, 137.33. Nitrogen's 14.007, 15.999. Again, I'm going to do that all on my calculator. Okay. So I have 261.338 grams per mole because again, I'm talking about my molar mass. So I do the problems themselves the same way. The difference is what unit I need to express them in. Okay. 21, what is the difference between the terms molecular mass and molar mass? Right? Molecular mass means we're going to be talking about just one molecule. So this is one molecule. And I'm going to have units of AMUs. Molar mass, I'm talking about 6.02 times 10 to the 23rd molecules. And I'm going to have units of grams per mole. So the person who wrote this explained it this way. Molecular refers to the mass of a single molecule, but molar refers to the mass of a mole of something or the mass of 6.02 times 10 to the 23rd atoms or molecules. Beginning mole conversions. The mole, often abbreviated as mole, is the link between microscopic atoms and molecules and the macroscopic things measured in grams. If you know how many grams of a substance you have and you know the molar mass, you can find out how many molecules you have. 2 examples of how to do this using a method similar to converting units is shown below. So this is asking if I have 23.5 grams of carbon, how many atoms of carbon do I have? So I start with my 23.5 grams. This is my molar mass of carbon from the periodic table. Grams have to be on the bottom so that they cross out. Moles are on the top. But I didn't want moles, I wanted atoms, so I know that 1 mole is 6.02 times 10 to the 23rd atoms. And so I get 1.18 times 10 to the 24th atoms. 2, how many molecules of carbon monoxide gas does it take to equal 50 grams? So this is saying if I have 50 grams of carbon monoxide, how many molecules of carbon monoxide do I have? So again, I'm starting with my 50 grams they gave me. This is calculated by having carbon and oxygen and the fact that you have one of each of them and adding those together. So that's where this 28 grams per 1 mole comes from. Okay, grams have canceled out. Now I know that 1 mole has 6.02 times 10 to the 23rd molecules, and I get 1.08 times 10 to the 24th molecules. So using your calculator, verify that if you have 125 grams of gold, you will have how many atoms of gold? Okay, and they're telling us we should get an answer of this. So I start with my 125 grams of gold. Grams of gold have to go on the bottom. Okay, moles of gold go on the top. I know 1 mole is going to be my mass of gold for my periodic table, which is 196.97. So grams of gold have crossed out. I have moles, but I want atoms. So I know that 1 mole of gold is 6.022 times 10 to the 23rd atoms. Okay. So now, again, this is why it's really important that you know whether you have to multiply or divide, right? I multiply by numbers in the numerator, I divide by numbers in the denominator. So I have 125 times 6.022 e to the 23rd, okay? And I want to divide that by 196.97. And I should have 3 significant figures, so I'm going to get 3.82 times 10 to the 23rd atoms. Okay, next one, consider 210 grams of this. How many molecules? So 210, sorry, I'm trying to figure out where this noise is coming from. I think I better find out. Sorry. Oh, I figured out where the noise is. It's the road grader going by. All right, 210 grams of N2O5 is how many molecules? Okay, so I have N2O5. Grams of N2O5 using my molar mass. And again, if you're struggling with this a little bit, we're going to do it in our notes too, okay? This comes from adding up 2 times the mass of nitrogen plus 5 times the mass of oxygen. So I get 108.009. Now I'm in moles. But I want molecules. 1 mole is that Avogadro's number. Okay, so now I'm ready to calculate this again. So I'm going to take 210 times 6.02 e to the 23rd, divide that by the 108.009, In terms of significant figures, this number only has 2. So my answer can only have 2, so I'm going to write it as 1.2 times 10 to the 24th molecules of N2O5. Number 24. If you exhale this many molecules of CO2, how many moles of CO2 do you have? So this one is asking 7.25 times 10 to the 24th molecules of CO2. How many moles of CO2 do we have? So 7.25 times 10 to the 24th molecules CO2. We know that it takes 6.02 times 10 to the 23rd molecules of CO2 to equal 1 mole of CO2. And that's what this problem was asking for. So I can stop right there. So I'm going to take 7.25 to the 24th and divide it by 6.02. And again, this has 3 significant digits, so I'm going to use 3, so I'm going to get 12.0 moles of CO2. Now, it asks how many grams of CO2 do you exhale? Now, one of the things I'm going to caution you about, and I'm going to demonstrate it right now, I don't want to use this answer. What if I've made a calculation mistake and that answer is wrong? Then my next answer is going to be wrong as well. So I'm going to go back to the 7.25 times 10 to the 24th molecules of CO2 and figure out how many grams of CO2 that is. Okay? So I want to go back to a number that I know is correct instead of using a number I've calculated that I might have made a mistake with. So molecules are going to be converted to moles. Moles are going to be converted to grams. I know that 1 mole is Avogadro's number of molecules. I know that 1 mole is, and to get the grams, I'm going to take 1 carbon, which is 12.011, plus 2 oxygens at 15.999, and get 44.009 grams. So now I'm going to take that number, multiply it by 7.25 e to the 24th, take that answer and divide it by Avogadro's number. And again, I want 3 significant figures, so I'm going to say 530 with a decimal, so that 0 is significant, grams of CO2. In a bag full of pennies, you may have 2.15 moles of copper. How many grams of copper do you have? 2.15 moles of copper. I'm going to use molar mass to convert moles of copper to grams of copper. And again, this comes from my periodic table, and because it's just copper, I look up my mass of copper on my periodic table, which is 63.546. So 2.15 times 63.546. I should have 3 significant figures, so I'm going to write this as 137 grams of copper. So again, it's very important to me that you set up your problems the way I've shown you how to set them up today. Again, we're going to go over this in our notes, so if you feel like this was a little quick or some of the things maybe aren't quite making all the sense yet, don't worry, we're going to talk about this in our notes. Have a great day. I'll talk to you tomorrow.